My name is Samah Al-Tantawi. I'm a postdoctoral fellow in the Intelligent Transportation Systems Research Group. My research interest is in traffic control, or in general the applications of artificial intelligence in transportation, and particularly intelligent transportation systems. As you probably know, the traffic congestion is everywhere because population is steadily increasing everywhere and worldwide. Of course, it affects badly the environment, the society, the economics. So, the solution that we developed, which is an adaptive traffic signal control system, you can think about it as a brain of the traffic light that allows the traffic lights at the intersections to self-learn how to control the intersection or respond to the fluctuations in traffic by changing the timings of the traffic light, and also self-learn how to collaborate with the neighboring intersections in order to minimize the travel time and the delay at each intersection. The system that we have developed for adaptive traffic signal control system, we call it Marlin. It stands for Multi-Agent Reinforcement Learning for Integrated Network. It's actually based on artificial intelligence method called reinforcement learning and also game theory concept. Because if you can think about the intersections, each intersection is affected by what's happening upstream, and also it affects what's happening downstream. So that's why they should coordinate together in a game theory setup. We have developed the software that should override the control logic in the traffic controller that's already in the cabinet in each intersection now. So this is an example of the traffic controller that's in more than 1,000 intersections in Toronto. And we connected, have the integration now between Marlin software and the controller. And this as a step before going to field testing. So as I mentioned, Marlin is based on artificial intelligence techniques that allow Marlin to have some unique features over the existing control systems in state of art and state of practice. So Marlin is self-learning, which minimizes the human intervention requirements. It's also decentralized, which has so many advantages over the centralized control systems that are already there. And it's model free. It doesn't require a perfect modeling for the traffic environment, which is very hard to be accurately modeled. And it's also developed to be generic, where different reinforcement learning methods can be used, not for a specific design for certain methodology. So the general concept of reinforcement learning is that there are two main components that are interacting: the agent, which is going to be the brain in the traffic light, and the environment, which is the traffic environment in the intersection area. And when the agent observes the state of the environment, which can be, for example, the queue length, the traffic flow that approach the intersection, the agent will take a certain action by, for example, extending the green for a certain direction or switching the green to another direction. Then the environment will be affected by that action, and then this effect will be measured in a form of reward that says how good the action was, and then the agent will use this reward value to update the control policy or the control law, which is the mapping between each state and action, and then it's going to reinforce the action that has better rewards. So for example here, because of the high queue length that on the left turn in that phase, so Marlin decided to extend that phase, that green for that direction. So with iterations, the agent will learn how to take the optimal actions at each state. So this learning, most of the time, it can be done in simulation environment first before going to the field. And then we can put this brain now in the traffic lights in the field, and can either continue learning in the field if any new situation happens, or it can just exploit what is already learned. As I mentioned, because of its nature of that moving learning target problem, because each intersection affects the other intersection. So in Marlin, each agent or each intersection plays a game with each one of the adjacent intersection in its neighborhood. So they exchange the actions because it can work in both independent mode, where each intersection just use the reward, which can be the saving in the delay, or coordinating with each other in the integrated mode. There are two sides that can benefit from Marlin. One side is the customers who are the urban traffic management of departments or the municipalities and cities, where they can benefit from the lower capital cost that Marlin provides compared to the centralized systems that require strong communications that are expensive, and also lower operation costs due to the nature of self-learning that Marlin used. Marlin, due to the decentralized design, it has lower capital costs because it doesn't need the same communications that centralized system use, such as Scoot. Scoot is the one that's implemented in most of the intersections that are using adaptive traffic signal control approach. And on the other side, the travelers or the end users, Marlin, based on the simulation results that we have got so far, Marlin helped reduce the delay for the travelers by 40% and the travel time by about 25%. So as you can see here, this is the average travel time during the peak AM hour, and every 5 minutes. So the green is for Marlin, and the blue one is for the base case scenario, while with the existing conditions, the existing traffic signal control methods. And it's not only minimizing the travel time, but also the variability, as I mentioned. I'm really eager to see this research implemented in different cities, like one of them is Toronto, of course, because I experience this traffic congestion in daily basis in Toronto. So I wish we can have this system implemented in Toronto and also different cities. Right now we have different discussions with different municipalities, and there is very strong potential and opportunities to have it implemented very soon in some municipalities, and especially because we are partnering with traffic controller company that is a US company that's going to help us commercializing Marlin. So hopefully we can see it in the streets soon.